Hello! In today's lesson, we are looking at Chapter 1, Section 7, An Introduction to Perimeter, Circumference, and Area. Our objectives are to find the perimeter and area of common plane figures and to use a general problem-solving plan. We start by looking at different formulas for finding the perimeter and area of different shapes. A square has all side lengths the same, so we can say the perimeter of the square can be found by multiplying 4 times all of the side lengths, or 4 times s. Alternatively, you could just add up all the sides, so it'd be side plus side plus side plus side. To find the area, it's side times side, which is side square. To find the perimeter of a rectangle, given its length L and width W, you would take 2 times the length plus 2 times the width, or 2 times L plus 2 times W. The area is just length times width. Triangle with side lengths A, B, C, base of B, and a height of H. To find the perimeter, you would add A plus B plus C. To find the area, it would be 1/2 the base B times the height H. Circle with a radius R. To find the circumference is 2 pi r. When saying finding the circumference of a circle, it's the same thing as saying find the perimeter of a shape. Area is pi r squared. Pi is the ratio of the circle's circumference to its diameter. We know pi to be 3.14. Example 1, finding the perimeter and area of a rectangle. For this problem, we have to find the perimeter and area of the rectangle. We need to use the formulas for the perimeter and area of a rectangle. We know to find the perimeter, it's 2 times the length plus 2 times the width. The length is 13, so it's 2 times 13, plus the width, which is 8, so it's 2 times 8. 2 times 13 is 26. 2 times 8 is 16. Add those together to find the perimeter of 42. Area is easy. It's length times width, so it's 13 times 8. 13 times 8 is 104. So the perimeter is 42 meters and the area is 104 square meters. Example 2, find the area and circumference of a circle. Find the radius, circumference, and area of the circle. Use 3.14 as the approximation for pi. From the diagram, you can see that the diameter of the circle is 12 inches. So the radius is 1/2 of the diameter, which 1/2 of 12 is 6 inches. Now use this to find the circumference and the area. Circumference is 2 times pi times the radius, so it's 2 times 3.14 times 6. Plug this into your calculator, you get this as approximately 37.68 inches. Area is pi r squared. We know pi as 3.14. Radius is 6. Here we have to take 6 squared first. 6 squared is 36, and multiply that by 3.14, and we get that the area is approximately 113.04 inches square. Example number 3, finding the measurements of a triangle in a coordinate plane. Find the area and perimeter of the triangle shown in the coordinate plane. So we are given triangle PQR, and we know that P is at 1 and 2, Q is at 4 and 8, and R is at 7 and 2. To find the area of a triangle, you need to find the base length and multiply that by the perpendicular distance that is created from the base to the vertex, called the altitude. So we got to find the altitude, or the height. We know that point S, this point over here, is located at 4 and 2. So to find our base length, we can subtract our x values. We could go 7 minus 1 to get 6. Or since this is on a grid, I can also count the distance over here. Since it's a horizontal line, I can go 1, 2, 3, 4, 5, 6, and say that my base has a measure of 6. To find my height, this is a vertical length. So again, I can count the distance from S to Q, or I can take the difference of my y values, and I got 8 minus 2 over here, which gives me 6 for the altitude as well. Again, and we'll just verify that by counting 1, 2, 3, 4, 5, 6. So the area of the triangle is 1/2 base times height. My base is 6. My height is 6. 6 times 6 is 36. 36 divided by 2 gives me an area of 18 square units. Our next step is to find the perimeter. Now with the perimeter, you can't count the diagonal distance because they don't fall exactly on each square unit. So in order to find the diagonal distance, I would have to use the distance formula. Remember, the distance formula over here is the square root of x2 minus x1 square plus y2 minus y1 square. I'm going to find the distance between P and Q. I'm going to write where P is, since I don't have the picture over here. P is at 1 and 2, and and q is at 4 and 8. Say that this is x1, y1, x2, y2. Plug it into the formula. We've got 4 minus 1 square plus 8 minus 2 square. 4 minus 1 is 3, 8 minus 2 is 6, 3 square is 9, 6 square is 36. Add those together and you get that this is the square root of 45. Now, square root of 45 can be simplified, and there's many ways that you can simplify the square root of 45. I use the upside down cake method. Some people use prime factorization. I'll show you how to use the upside down cake method over here. So you're going to take 45, turn the square root upside down, and divide it by the smallest prime number possible. Smallest prime number that I can divide 45 by is 5, which gives me 9. Smallest prime number I can divide 9 by is 3, which gives me 3. Smallest prime number I can divide 3 by is 3, which gives me 1, which I call my upside down cake. There's my candle. Anytime I have a pair of numbers, I'm going to take one of the pair, get rid of the other one. So he's going to go outside the house. The only number that's left, which is 5, goes back inside the house. So the simplified form of square root of 45 is 3 square root of 5. We also have to find the length between Q and R. R is located at 7 and 2. To match what they did with the notes, I'm going to just redo the x's and y's. This is going to be now, R is going to be my x2, y2, and Q is going to be my x1, y1. So I've got 7 minus 4 square, and then the difference of the y would be 2 minus 8. 7 minus 4 gives me 3 square. 2 minus 8 gives me negative 6 square, which looks the same like this because 3 square is 9 and negative 6 square is 36. 9 plus 36 is 45, so I've got the square root of 45. Simplify that and you get 3 square root of 5. So to find the perimeter, you're going to add up all of the sides. We have 3 square root of 5 plus 3 square root of 5 plus 6, which goes back from the original. So I'm just going to redraw this over here. This is 3 square root of 5. This is 3 square root of 5. And this length is 6. Add those all up. Remember, you are grouping like terms. So in this case, we're going to go 3 plus 3, which is 6 square root of 5. And we're just left with 6. Now you can plug this into the calculator and get a decimal answer, or you can leave it in this form. All right, checkpoint problems number 1, 2, 3, and 4 are yours. In checkpoint problem 1, 2, and 3, you are to find the area and perimeter or circumference of the figure. Use 3.14 as an approximation for pi. In checkpoint problem number 4, find the area and perimeter of the triangle defined by J at 1 and 4, K at 9 and 4, and L at 4 and 0. Let's take a look at a problem-solving plan. A problem-solving plan is important because in any math class that you go to, you will always be asked to solve word or story problems. So you need to have a plan of action on how do you attack these kind of problems. The first thing you need to do is ask yourself what you need to solve the problem. Then write a verbal model or draw a sketch that will help you find what you need to know. Label known and unknown facts on or near your sketch. Use labels and facts to choose related definitions, theorems, and formulas or other results you need. Reason logically to link the facts using a proof or other written argument. Write a conclusion that answers the original problem. Check that your reasoning is correct. Let's put that problem-solving plan into action. In example number 4, we are asked to find the area of a triangle. So we are given a kite design. You are designing a triangular kite with a height of 64 inches and an area of 496 square inches. What is the base of the height? The hint over here that they give you is it might be helpful to draw a sketch of a kite and label the given dimensions. Remember to always check your answer. They gave us a hint. They asked us to draw a picture. So let's draw a picture of a triangular kite. Triangular kite means that the kite looks like a triangle. The height is 64 inches. Remember, the height is the perpendicular distance between the base to the vertex. We know that to find the area of a triangle, it is 1/2 base times height. So we can write a verbal model. The area of the kite is 1/2 times the base of the kite times the height of the kite. We know the area of the kite. We're given that that's 496 square inches. We need to find the base of the kite. We have that as B, so that will be our value that we're looking for. And we're also given the height of the kite, which is 64. So we're going to plug plug in what we know and what we're looking for. We know the area of the kite is 496. We know that the area for triangle is 1/2 base, which is b, that's what we're looking for, times the height, which is 64. Our first thing we're going to do is try to get rid of this fraction by simplifying 1/2 and 64. We know 1/2 of 64 is 32 times the base, which is 496. Isolate b by dividing both sides by 32, and you get b, your base, is 128. So my base of my kite is 128 inches. And we can double check our work and see if we got the correct answer by taking the area is 1/2 times the base, 128, times the height, 64. We take 1/2 times 128 times 64. We do indeed get 4,096 inches square, and so our answer is checked. Checkpoint problem number 5. You need to buy mulch for a rectangular flower garden. The garden is 6 feet wide and 12 feet long. One bag of mulch will cover 8 square feet. How many bags of mulch should you buy? Give this problem a try, and I will see you all soon.